got more math for you. You get a little angry. I don't know why. I'm doing math, so I should be happy. So. Okay, so this is what it looks like. Okay, so the velocity is positive for a while, so that means it's going in a positive direction, and then it's negative for a little bit, and then it's positive again, and it's negative. And we just know these specific points. We don't know what looks exactly like this. We don't know that these 255s are maximums or that 29's minimum. Actually, it could go up and down crazy. All we know it's a differentiable function. I guess that's all we know. Justify where there must be at least one time over the interval of 0.3 to 0.8. So over this interval, where the acceleration, the derivative of the velocity, slope of the tangent line of the velocity curve equals 0. Okay, so if we look at this, you can see the velocity is 55 for both of those. If it's a smooth curve, there's the mean value theorem proves that there's at least one value c in between 0.3 and 2.8, where the slope of the tangent line equals the slope of the secant line connecting those 2 points. So all we need to know in order to use the mean value theorem is that it's a differentiable function, which also means that it's a continuous function. So for A, we can say since V sub P of t is differentiable from 0.3 to 2.8. Oops. It's also continuous. .3 to 2.8, right? Those are the conditions. So by the mean value theorem, V sub P of prime of t equals 0. Because V sub P prime of t equals I think that's good enough, right? This, I said by the mean value theorem, I even wrote it out. And we listed the conditions of the mean value theorem. I think we're good. So let's go B. Use a trapezoidal rule with 3 subdivisions to estimate that area. So we're just going to find the areas of those 3 things. From 0 to 3, the trapezoid looks like a triangle. From 0.3 to 1.7, trapezoid looks like that, where these are the 2 parallel bases, and the height is the distance between 0.3 and 1.7, and then on 1.7 to 2.8, again, you've got these 2, and that's what the trapezoid looks like. So we're going to estimate this V sub P of t dt is about, so it's the average of the bases times the height. In the first interval, it's 0.3 minus 0 is the height. And the average of the bases is 0 plus 55 divided by 2. And the next one, it's 1.7 minus 0.3 times the average of the bases. Oh, I should put this in parentheses actually. And that's negative 29 plus 55. And then the third one is 2.8 minus 1.7. We multiply that by the average of the bases. So 55 minus 29 divided by 2. And that'll give us that estimation. Hopefully we can do that quickly on the calculator. So it's 0.3 times 55 halves plus, what is it, 1.4 times, well, what is that, 3026 divided by 2 plus 1.1 times, same thing, right? 30, 40, 55. I know. 26 divided by 2 is 13, right? And we get 40.75. Just making sure I got the right number. Pretty sure it is. Okay. 40.75. Okay, so C. The second particle, Q, moves along the x-axis also over the time interval from 0 to 4, and that's the function Q. So I'm going to plug that in the calculator. 45 times the square root of t times a cosine, 0.063 t squared. Oh, I put that in y too. It doesn't matter, I guess. Okay. Find the time during which the velocity of particle Q is at least 60 meters. So we want to find when the velocity equals 6. So it looks like we just go V sub Q of t equals 60. And then we can find those times. Okay. It's from 0 to 4, right? So I'm going to graph 60. And I'm going to change the window from 0 to 4. Change the y max to 70 maybe. Try that. And it looks like it is 60 here and there. Okay, so there are 2 times. And let's find those times. So you already have the equation that I'm solving right here, so we're good. Intersection. Ooh, it's close. 1.8662 and time equals $3.5192. 3.5192. Okay, so those are the 2 times. What do I have to do? Find the time interval, at least 60. Find the distance the particle traveled. Okay, so the time interval is there to there. And the total distance traveled That is, ooh, you know what? I'm going to assign this A 1.8662 and B is 3.5192. I'm just going to integrate this from A to B. And since it's the total distance, we need the absolute value of this. Okay, so deactivate that one. Oh boy. Okay, so we can do this. We're going to integrate this. 9. Oops. From 1.8662 to 3.5192 y2 dx. Let's see, one more thing. This is the total distance, so I screwed that up. I need this to be the absolute value of y2. There, that'll do it. One 106.1092. Okay, so that's the total distance to be meters per hour, so meters. Okay, and for D, at time equals t, the position is negative 90, use the results in part B in the function v of q from part C to find the approximate distance between those. So we're going to find the distance between is approximately 0 to 28, 2.8 v sub p of t minus, and I'm going to do, remember it starts at negative 90, so the position is negative 90 plus the integral from 0 to 2.8 of v sub q of t dt. Okay, and that'll give us the approximate distance between. If it's positive, you know, maybe we take the absolute value of this, and that'll definitely do it. Okay, so we can do that with your calculator too. Negative 90 plus the integral . 0 to 2.8. Instead of putting in a grade that doesn't reflect the grade. So 45. And if we subtract 40.75, we get 5.1877. $5.1877